All right, here's that duopoly situation we worked on in class today. Here we have two firms, Airbus and Boeing. Demand is given by P equals 120 minus Q, and P is in millions of dollars. Q is the total number of planes. Cost function, 4Q plus 20 for each firm, and then marginal cost is just constant at 4. Collusive outcome, shared monopoly, and then cheating firms assume that the other will be producing that shared monopoly output. So let's construct the game in strategic form. I'm just going to work through each case. I've got a panel where I can record the answers to the game. Let's start with the collusive case, the shared monopoly. Well, if the demand is P equals 120 minus Q, the marginal revenue function is 120 minus 2Q. We set that equal to marginal cost. And we get Q is equal to 116 over 2, which is 58. So Q1, we'll call it Airbus firm 1 and Boeing firm 2. They both produce 29. They're sharing the monopoly. Price is equal to 120 minus 29, which is 91. I'm sorry, it's not. Price is equal to 120 minus, no, got my eraser on, 120 minus aggregate quantity, that's 58. So 120 minus 58 is 62. Say 120 minus 20 gets us to 100. That leaves us 38 more. That's 62. All right, sorry. Profits. Profits for firm 1 are the same as profits for firm 2. And those are price times quantity. 29 is the quantity times 62 is the price, minus 29 times 4, that's variable cost, minus 20. And we get 1,662 million for each. Let's enter that in to the payoff matrix. Now, what happens when one firm cheats? In that case, let's just make Airbus the cheater. In that case, the firm faces the demand curve P equals 120 minus the 29 that it assumes the other firm is producing, minus Q1, marginal revenue, then is, that's my 91, minus 2Q1, set it equal to 4. You get 2Q1 equals 87, so Q1 is equal to 43.5. Q then is equal to 43.5 plus the 29, that's 72.5. So price is equal to 120 minus 72.5, which is 47.5. And the profits of firm 1 are 43.5 times 43.5 minus 20. I subtracted the $4 average variable cost from 47.5 to get 43.5. And that turns out to be the cheater makes 1,872.25 million. And let's see, I'm running out of room here. I'm going to isolate this one off. The second firm, the one that isn't cheating, is going to get 20. They're producing just 29, and their price minus average variable costs is 43.5, and then we subtract off their fixed costs. And when we do all that, we get 1,241.5 million. So let's go ahead and enter those values into our table. And we can enter them in two places. First off, if Airbus cheats, they're going to make 1,872.25 million. So that's 1.8. Oh, 872.25. There we go. Million. And then in that case, Boeing would be making 1,241 million. 241.5 million. 1,241.5 million. Got it. And then it's just symmetric game. So if the shoe is on the other foot, 1,241.5 and 1,872.25 million. We know where we're going to go. Well, let's go ahead and derive that result where they're both cheating. If they're both cheating, demand is the output is 43.5 twice, so price is 120 minus 87, which is, let's see, it's 100 minus 67. Is that right? 100 minus 20, 67. Yeah, of course. And then profit for firm 1 is equal to profit for firm 2, and that's equal to output of 43.5, price minus average variable costs of 29 minus 20, and that turns out to be equal to 1,241.5. And again, these are millions. And so there we verified it. Let's go ahead and enter that. 1,241.5 million. 1,241.5 million. All right, that's our duopoly problem.